All right, today we are starting chapter 1. We are going to be transforming equations using addition and subtraction. So we are actually going to start solving equations today. For our warm-ups, what type of problems are these? What do we need to do?
Form operations.
Disagree. Dominic?
Simplify.
Simplify by doing what?
Oh, you gotta combine like terms.
Combine like terms. That's what these problems need us to do. So for warm-up number 1, what terms can combine?
C to C.
I sort of agree. We keep the sign that's in front of the number. So we have plus 6 minus 6. Janai already said it. It comes out to be 0. They cancel each other out. So what are we left with? X. Number 2. What is combining?
Negative 18 and positive 18.
Good. We've got minus 18 plus 18. Those combine to 0. Again, they cancel out. So we're left with T. All right, number 3. What's getting combined?
2 and negative 2.
Good. 2 and negative 2. Even though they're not right next to each other, they can still combine because they are like terms. What do we end up with? 0. Okay, 2 minus 2 is 0. So our final answer for this is X. All right, on number 4, what's getting combined?
Negative 4 and 4.
Negative 4 and positive 4 combined to give me 0 again. So we're left with R. Okay, number 5 is kind of the wild card here. What's combining?
13.
13 and negative 13 combines to give me 0. So what am I left with?
Negative.
Negative M. You got to keep the sign that's in front of that term. On all our other ones, they were positive variables, but this one's got a minus sign in front of it, so it stays with it. All right, we've got a couple definitions to get down. All right, an equation is a statement that two expressions are equal. So sometimes you would see that just with number expressions, like 2 plus 3 equals 5. That's still an equation. Or it might be something that involves a variable, like x plus 2 equals 5. Okay, so if you want to put an example for that, this would be an example. All right, a solution of an equation is a value that makes the equation true. So what would my solution for this equation be? Dominic? 3. Okay, we know that 3 plus 2 is what gives us 5. A linear equation in one variable, it's a big term, is an equation that can be written in the form ax plus b, where a and b are constants and a does not equal 0. So I want to talk about this whole ax plus b real quick. What's happening between the a and the x? They're being multiplied, and what's happening with the b and the rest of that? It's being added. So we've got 2 different operations going on there. We're going to be dealing with that general form a lot this year. Inverse operations are 2 operations that undo each other. Can anyone think of an example? 2 operations that would undo each other or cancel each other out. So a positive and a negative is close. So in that sense, we'd probably think about it as addition and subtraction. So we can add and subtract. Can anyone think of another pair of inverse operations? What's our other two pair of operations? Division and multiplication. So multiplying and dividing will also undo each other. So those are also inverse operations. There are more, but those are the ones that we will see most often. At least for now. Equivalent equations are equations that have the same solution. Okay, the addition property of equality. This is a big idea. I would at least get the algebra part down. If you don't get the words down, I'm not as worried about that, but we do need to have the algebra part. So I'd have the title and the algebra. And I will read to you the words. Adding the same number to each side of an equation produces an equivalent equation. So what that means is that we can add something to both sides. In this algebra example, we added C to both sides, and we're saying that that doesn't change the equation. It produces an equivalent equation. The subtraction property of equality. Again, we should have a title. We should have the algebra for it. I will read you the words. Subtracting the same number to each side of an equation produces an equivalent equation. All right, what I want you to write down from this slide is the second bullet point. Whatever you do to one side of the equation, you must do to the other. Whatever you do to one side of an equation, you must do that exact same thing to the other side of the equal sign. So let's start working on some examples. If you want, you can write at the top that our goal here is to get variable alone. So, for example, you want it to just be x equals some number, or whatever the variable is. So when we're solving equations, that is our goal. What the last slide went through is kind of some steps to help us with that. So one thing that some teachers tell us to do, which if you want to do it, it's good. If not, I'm not going to force you to, but is to either box or circle the variable itself. So that way we're focused on what's trying to be alone. On number 1, that would be x. We're trying to get x alone. That's the whole goal. So some teachers will say you have to put a box around it. Box in your variable to help you focus on what we're trying to get alone. After that, we are going to do inverse operations to get our variable alone. So right now it says that we are subtracting 6. So our inverse would be to add 6. But if we do it to one side, we have to do it to the other side of the equal sign. So that's why some people also will put like a line down through their equal sign. So that way they know where they're adding both sides of that line. So when we do that, negative 6 plus 6 cancel out. That's what we want to have happen. X equals 15 is great. Okay, on number 2, what are we trying to get alone? What are we going to have to do to both sides of our equation? Subtract 7. Dominic, what do we get?
3.
Y equals 3. Make sure when you are answering these questions, you put X equals the number. Y equals the number. Okay, if you don't have that, if you just put a number, it's not fully correct. We aren't just simplifying, we are solving. On number 3, what's getting a loan? What do we need to do to both sides? Subtract 5 from both sides. Okay, the opposite of adding is subtracting. So those will cancel each other out so that we're just left with x equals 9 minus 5 is 4. On number 4, what are we trying to get alone? The x. We're always trying to get a variable alone. So, minus 5 is going to zero this 5 out. We want the x alone, so we've got to get rid of what's next to it. But if we do it to one side, got to do it to the other side. So now our x is actually on the right side, and that's fine. Good. 2 minus 5 is negative 3. Okay, if you're still not great with your integer operations, invest in a calculator. Questions before we continue? Okay, let's keep it moving then. All right, number 5, what are we getting alone? The y. What do you think we need to do? Good. We need to zero out a minus 4 or negative 4. So to cancel it out, we have to add 4, but we have to do it to both sides. So we end up with y equals a positive 4. Number 6, what are we getting alone? R. What do we need to do to both sides? Add 1. So, what are we left with? R equals 0. You need that whole statement. Okay, so negative 1 plus 1 cancels out, and then it cancels out on the other side or equals 0. If you just write down an R or just R equals without a number there, it's wrong. It's got to equal 0. What do we get on number 7? 6?
I got a negative. I got positive 4s.
Okay. What are we trying to get alone?
Equal s.
Okay, we're trying to get the s alone, which means we need to get rid of what number?
I think 4.
No. We got to get rid of the number by the s, so that would be the minus 2. To get rid of it, we add 2. And that is how we would get 6. If you write it as s equals 6, that's the same thing, so I don't really care if you write it forwards or backwards. What do we get on number 8? 4. How do we get it? Good. Add 9 to both sides. And our answer should read what altogether?
10 equals 0.
T equals 4. You should have the variable equals the solution. Questions before we move on? Number 9. What do we get? Hunter? I think I disagree. Janiyah, what'd you get? Negative 9.8 sounds better to me. We would have to do what to both sides? Just subtract 5.2. So if we call it subtracting a negative, then we are changing it. So subtract 5.2 is a good way to go about this. That's what gives us the negative 9.8. Again, if you're not sure about your operations with integers or with positive and negative numbers, get a calculator. Okay, it'll help you out and you can double check yourself. What do we do on number 10? Good. Subtract 26. What do we get for D?
41. Negative 41.
Good, negative 41. Questions, concerns about those two?
Like,
26.
Good. On 11, we should have gotten that T is equal to 26.
Whoa.
Who got number 12? Andrew?
Negative 3.
Negative 3 for X.
Also, can I shut the door or can I window?
Yes, it is a negative 3. Anything else? Okay. Let's move on to these two. We're going to skip those ones. So we can rename these as 13 and 14. On number 13, what do I need to do to both sides?
Add 4.7.
Good. We have to add 4.7 to both sides. Anybody know what we're going to get? Anyone know if it'll be positive or negative? It'll definitely be negative because the bigger number is negative. Negative 1.3. All right, on 14, what do we need to do?
Add 1/3.
Add 1/3 to both sides. If you want to write your fractions out next to each other, negative 2/3 plus 1/3, if that helps you add them, that's fine to show some work. What do we get for G? Liam? Negative 1/3. Okay, when we add or subtract fractions, we need a common denominator, which we already have. So we add the numerators. Negative 2 plus 1 is negative 1. We keep the same denominator. Okay, so our problem solving steps will be understand the problem, make a plan, solve the problem, and look back, or we can call it check. So the first step is to understand the problem, and in my opinion, it's the most important step. We need to identify what is the unknown, what information is given, and what's being asked. If we don't know what it is that we do and don't know, or what the question is asking us to do or find, then we've got no hope of solving it. Okay, so we have to understand what's going on. Make a plan. Sometimes it helps to think ahead about what types of operations might be involved. Number 3, solve the problem. So actually execute your plan, check your steps. The 4th step is to look back or check your problem overall. Check that your solution makes sense. If the question asks how many bags of apples do you have, and you tell them $14, does that make sense? No. They ask for bags of apples, not for dollars. So make sure that your answer matches up with what's being asked of you. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to 47 degrees at 9:27 a.m. How many degrees did the temperature fall? So first of all, do we need to know the date? No, that doesn't matter to us. Do we need to know where they are? No, doesn't matter to us. We need to know that the temperature started where? Starting temp was 54 degrees Fahrenheit. That's something that is important to us. We need to know that. Do we need to know that it was at 9 a.m.? No, they don't care about the time. They don't ask us about the time. What was our ending temperature?
Negative 47 degrees.
-47 degrees. Fahrenheit. Again, we don't care about what time it was at. They're asking us how many degrees did the temperature fall. Now you could think through this kind of logically, okay, or we could set up an equation. So if I'm using a variable, what variable do you want to use? N?
No.
T?
Or
Oh.
It doesn't matter to me. Pick one. So I like to use T, sure, just make sure it looks like a T. If you want to use X or N, that's fine. And this is going to represent what it is that we don't know yet. What is it that we're trying to figure out, or what we don't know? How many degrees the temperature fell? So that's what we're going to define it as. How many degrees temp fell? Okay, so if we were to take our starting temperature, 54 degrees, and add to it how many degrees it fell, we would end up at our stop temperature, our ending temperature of -47. So where we started plus how much it fell gives us where we ended up. Questions about the equation we set up? Dominic?
Very quickly,
Mhm.
solve for this one.
Yes, that's what we need to do. That's step 3 is to solve it. What are we going to do to solve this one? Subtract 54 from both sides. And what do we get for T? -101 degrees Fahrenheit. As I read through number 2, I'm going to stop at the end of each sentence and ask for important information that we should circle or highlight. You thought the balance in your checking account was $68. What's the most important part of that? The $68. Okay. When your bank statement arrives, you realize that you forgot to record a transaction. Is there anything in that statement that you think we're going to use? No. They didn't give us any numbers. They're just giving us a story. So that whole sentence doesn't really matter a whole lot to us, except for we're getting the idea that this number is going to change. The bank statement lists your balance as $26. What's important there? $26 was our actual balance. Write and solve an equation to find the amount that you forgot to record. Okay? So, our balance that we thought it was, thought we had 68, actually had 26. Okay, so then what do you want your variable to be? A? Sure. A is going to represent what? Liam? The what? Amount lost or amount forgotten. Good. So the amount forgotten or lost. I like forgotten because we probably didn't really lose it. We just forgot about it. Okay. So if we take how much we thought we had, what do you think we're going to want to do with the amount forgotten? subtract it because it's getting taken out or taken away from our amount. Gives us how much we actually had, which was 26. Now we're going to have to be careful in solving this one. First step, we're trying to get that A alone. Subtract 68. I heard some people say it softly. Now when we do that, what sign is still on the A? A negative sign. Don't drop that off. And what do we get when we take 26 minus 68? Negative 42. Is A all alone? No. This would read as negative A, or the opposite of A. So if negative A is negative 42, what is positive A going to be? Positive 42. So we change one sign, we change it on the other side. Okay, we didn't want negative A, we wanted A. So the amount that we forgot was how much? $42. Would it make sense to say we forgot negative $42? No. So that doesn't even make sense to say. That's the whole check step. The homework assignment is out of the book. It is on pages 8 and 9. If you have not been issued a textbook yet, you can still get it digitally, meaning on your phone, a laptop, Chromebook, computer. These are the numbers in the parentheses are the numbers that you're doing. The pages are 8 and 9.